Hello students, in this second session we are going to see a problem f of x equal to sin x where x belongs to closed interval a comma b. We have to check whether this function f of x equal to sin x is of bounded variation. So first I do a partition of the closed interval a comma b as x naught, which is nothing but a, x1, x2, so on up to xn minus 1 comma xn, where this partition will be in increasing order. x0 will be less than x1, x1 will be less than x2, which will be less than x3, so on up to less than xn minus 1, which is less than xn, where x0 will be the point A and xn will be the point B. So I have to check whether this function is of bounded variation. In order to check that, I have to use this condition summation k equal to 1 to n modulus of del fk, which is equal to f of x1 minus f of x0 plus modulus of f of x2 minus f of x1 plus so on up to modulus of f of xn minus f of xn minus 1. So f of x1 will be, in this modulus f of x1 will be modulus of sin x1 minus sin x0 plus modulus of sin x2 minus sin x1 plus so on up to plus modulus of sin xn minus sin xn minus 1. Okay, now you have to see here this function f of x is of sin x. By mean value theorem, what I know is, if a function, I am stating the mean value theorem here, if a function f is defined on closed interval a comma b and f is continuous on closed interval a comma b, also f dash exists in open interval a comma b, then what will happen is there exists a point c belongs to open interval a comma b such that f dash of c equal to f of b minus f of a divided by b minus a. Now our function f of x equal to sin x satisfies all the conditions of mean value theorem. So I am applying mean value theorem for the function f of x equal to sin x. So if I apply, what I will get is f of xn minus f of xr in general, f of xr minus 1 will be, what I will get is, I have to find f dash of x sin x. If I differentiate, I will get cos eta into xr minus. Okay, hope you understood. I am applying mean value theorem f dash of c, it is given by f of b minus f of a into b minus a. Cross multiply this, I will get f of b minus f of a will be equal to b minus a times f dash of c. Okay, so I am in general for this function f of x equal to sin x, I am applying mean value theorem. So f of xr minus f of xr minus 1 equal to cos of eta into xr minus xr minus 1, where eta belongs to the open interval xr minus 1 comma xr. Okay, are you able to follow? So next what I am going to do is I am going to apply this here. I am going to apply this here in this. So what I will get is sin x1 minus sin x naught, that is modulus of sin x1 minus sin x naught will be equal to modulus of cos eta into x1 minus x naught. So this is in the product, so I can take modulus of cos eta into modulus of x1 minus x naught. Okay, for sin x1 minus sin x naught I will get this value. For sin x2 minus sin x1 I will get cos of eta 2, this is eta 1, eta 2, x2 minus x1. Continuing in this manner, I will get summation k equal to 1 to n modulus of del f k, which is equal to, I am replacing that sign, I am replacing sin x1 minus sin x naught by cos of eta 1 into modulus of x1 minus x naught. Okay, so modulus of cos of eta 1 into modulus of x1 minus x naught plus modulus of cos eta 2 into modulus of x2 minus x1 plus so on up to plus modulus of cos of eta n to modulus of xn minus xn minus 1. Okay, next I know that the value of mod cos eta r in general will be less than or equal to 1. So summation k equal to 1 to n mod del f k, this will be equal to modulus of x1 minus x naught plus modulus of x2 minus x1 plus so on up to plus modulus of xn minus xn minus 1. So it is same as f of x equal to x. For that function also I got this value. So this will be equal to x1 minus x naught plus x2 minus x1 plus so on up to plus xn minus xn minus 1, which is equal to b minus a. B minus a is some real number and it is positive real number, which implies my function f of x is equal to sin x is of bounded variation.